Hello everyone, welcome to Sweetie Speaks official YouTube channel. Today we are going to learn about very important construct in system verilog, which is fork join. A lot of people get confused when talking about fork join. Today we are going to learn about this construct in very easy language with all examples, and I'll also explain each and every code, each and every line of code. We'll execute all the codes, we'll analyze the output, and we will understand why the output has come like that. Now let's get started. First, let us understand what is fork join. Fork join is a construct which is provided in system verilog. It helps us to provide support for concurrent and parallel threads. In any operating system, there is a concept of multi-threading. Similarly, in system verilog also you can have multiple threads. Now these threads can either execute concurrently, concurrent means in sequence, or they can either execute in parallel. If I want to provide support for this concurrent and parallel threads, fork join is one way to do it. Inside fork join, there are processes, or I can call them threads. Each and every process inside fork join runs in parallel. There can be multiple processes or threads inside one fork join, and each of them will run in parallel. And if you are using begin and block inside your fork join, then all the statements inside begin and each and every statement which is inside begin and will run in sequence, or I can say concurrent. Threads or processes will run in parallel. Each and every statement in begin and will run in sequential or concurrent manner. Using fork join, multiple procedural blocks can be spawned off at the same time. It means you can start multiple procedural blocks at the same time. What are different variants of fork join? You can say there is fork join, there is fork join any, and fork join none. We are going to understand in detail about each and every of this construct, and we are also going to see coding example. Just remember there are three variants: fork join any, and fork join none. It is possible to nest the fork join, which means you can use fork join inside another fork join. That can also be done. And fork join can also be disabled. What is the code to disable fork join? Disable fork. If you want to disable fork join, you can use disable fork. Let's see what are different variants of fork join. The first variant is fork join itself. In fork join, what happens is each fork join will be called by a parent process. Say for example, I have initial begin block in which I am calling fork join. So what is the parent process for fork join? The initial begin block which call the fork join will be its parent process. So what happens in fork join? It will block the parent process execution until all the processes within this fork join are completed. Until then, it will not execute the parent processes which are coded after the fork join. The next variant is fork join any. The name says any. It will block the parent process only until any one of its processes completes. As soon as any one of its process completes, the parent processes will also start executing. And fork join none. As the name suggests, none. It means it should not block the parent process at all. So in fork join none, it will continue the parent process execution along with all the processes inside it. Let us understand this with the help of diagram. Here, if you see in fork join, I have three different processes, or you can call it three different threads. This fork join is not coming out until all of its threads are completed. Once all of the threads are completed, only then it will come out. In case of fork join any, if any of its threads, say this thread one completed execution first, so it completed, one thread completed. So it is coming out, and the parent process, the statements after this will also start executing. In case of fork join none, if you see, even if none of the processes are completed, still the parent process is also continuing to execute along with this fork join none. Now let us understand all these things with the help of code. This is the code for fork join in system verilog. Here I have a module fork join. There is a parent process initial block. If you see, this initial block is the parent process inside which your fork join is defined. That's why initial becomes the parent process for the fork join. Now inside your parent process, before fork join, you have two display statements. These two display statements, one is having the delay of 0 and the second is having the delay of 10. After that, you have fork join. Inside fork join, you will have multiple threads. Each and every statement inside fork join is a thread itself. And if you are having any begin end blocks inside the fork join, all these statements which are inside begin end will execute in sequence. But this begin end itself is one thread. Begin end is one thread, and the statements within begin end will execute in sequence. Now let's do one thing. Let's try to understand this code. So you have two statements in the parent process before fork join. Then you have three different threads. One first thread has only one statement with the delay of 10. The second thread has two statements, and each of them are inside begin and block, so they will execute in sequence. And then you have the third statement after begin end, which will be a third thread. And finally, after join, you have two more statements. One is with a delay of 0 after fork join, and another is with a delay of 10 after fork join. Now let us run this and we will analyze the code. Mainly we need to see when each statement got displayed, and we need to analyze whether the delays are correct or not. The basic thing is, once you enter fork join, each and every statement inside fork join is a thread, and each and every statement which is inside begin end will execute in sequence, and begin end itself will be treated as one thread. So let's analyze the output. Here, if you see, at delay 0, the first statement got executed. The second statement got executed at a delay of 10. The next statement which got executed at a delay of 10 is thread 2 inside fork join. So here, if you see, this statement has a delay of 0, but this statement is inside fork join. Fork join is after these two statements. So this statement had a delay of 10. That's why this delay 10 will get added to each and every statement, each and every thread inside fork join. That's why this got executed at 10. And then at 20, this got executed. 10 plus 10, the total delay became 20, and then the statement got executed. And then also this statement got executed at delay 20, because in fork join, this and this, these are three threads, and all these three threads execute in parallel. Since these two threads have the same delay, they will execute in the same time. This at 20. Why 20? Because before fork join, there was a delay of 10. So 10 plus 10 became 20. And similarly here, this will execute in parallel with the first thread. And the total delay became 10. 10 this plus 10, which was 20. So that's why the statement in thread 3 got executed at delay of 20. And then the statement inside begin end, the second statement had a delay of 20. Since it had a delay of 20, this 20 plus this 10, it became 30. So this got executed at the time 30. And once everything is completed, you are outside the fork join. fork join means everything should get completed. So here I see everything got completed. Each and every statement inside all the threads got executed, and finally it came out. So once it came out, it displayed after fork join with the delay of 30, because the total delay to execute the fork join all statements in parallel was 20, and before that there was a delay of 10. 10 plus this 20 is maximum. If you see, the thread 1 in fork join will only take 10, delay of 10. The thread 3 will also take a delay of 10, but thread 2 will take total delay of 20. So that's why total delay of fork join became 20, and before that there was a delay of 10, which means fork join will complete at 30, and after that this statement got displayed at 30, and after a delay of another 10, which is 30 plus 10 is 40, the last statement got executed. Now, if you remember, we also said there is a construct to disable fork. This is the construct disable fork. What happens if I disable fork join? Remember, fork join means all the statements should complete execution. Only then it will come out. So here disable you are writing after coming out of fork join. So if you run this, okay, let me try to rerun. So if you run this, nothing changes. Why? Because it is fork join. And in fork join, what happens? It will come out only after everything got executed. Now let's change this fork join with fork join any. Any means if any one thread got completed, you can come out. So any one thread means thread 1 is having a delay of 10. This first thread itself will get completed first. So let's run this and see. So here what happened before fork join got printed, the two statements before fork join, then the first statement inside thread 2 didn't have any delay, so that got printed, and inside thread 1 there was a delay of 10 which got printed at 20, and since one thread already completed execution, it can come out now. So it came out, and it did not execute any other statements, because after coming out of join any here, uh, here it came out of join any at 20 after execution of this thread, and after that I disabled fork. Since I disabled fork, what happened? Since I disabled fork, it did not execute any other statements, and after that whatever the two statements were there after fork join, those got executed. Now let's try to comment out disable. What happens if I comment out disable? Let's rerun. See, now you have commented out disable, right? So once you commented out disable, what happened? Let's understand. Any means if any one thread completes execution, it will come out. Now let's analyze one by one each statement. First two statements which got printed are before fork join. Okay. Now inside fork join in thread 2, the first statement is without delay. So that's why it got executed at 10. Okay. But thread 2 did not complete execution, because inside thread 2 there are two statements. The second statement did not complete execution. It means none of the thread has completed till now. The next statement which we see displayed will be thread 1. So a thread 1, this will display at 20. If you see thread 1, this got displayed at 20. Now once this statement got displayed, one thread execution completed. One thread execution completed at 20. As soon as one thread execution completed, it can come out. it can come out and start execution of parent process. Which is the parent process? Initial block. It can start executing the parent process in parallel with the other statements inside the fork join any. So at 20 it came out. At 20, if you see, with a delay of 0 after fork join, means at time 20 this statement should get executed. If you see, at time 20 it got executed in fork join any. Why? Because as soon as one thread completes execution, it can come out. In case of fork join, if you remember, this got executed at 30. Why? Because all the thread completed execution at time instance 30 in case of fork join. But since this is fork join any and one thread completed execution at 20, that's why it came out and it displayed this statement. Now, after a delay of another 10 inside the fork join, already a delay 10 has completed. After a delay of another 10 inside the fork join, this particular statement can get executed, right? After this statement got executed here, after another delay of 10, 20 plus 10 was 30, and at 30 the statement also completed and the statement also completed. Because after a delay of 20, after a delay of 20, another threads inside fork join any, and the processes which are in your parent process, which is initial block, were executing in parallel. Simply just remember, in fork join any, as soon as one thread completes execution, it can come out and it can start executing the statements which were after the fork join any. And if you disable the fork, at that time the other statements after the first thread will not get executed. As soon as the first thread completes, none of the other statements will get executed if you use disable fork. Now let's see what happens in join none. None means even if none of the statement executes, you can start running the parent process. That's what none means. So if you see here, the first two statements before fork join got executed. And along with that, if you see, even after fork join is executing in parallel with fork join none. Why? Because it is none. Even if none of the threads have completed, you can still execute the parent process in parallel. So the first parent process, the first statement is having delay of 0. So if you see, that's why this after fork join also started executing along with this fork join. And then the first statement with 0 delay inside the fork join got executed, this thread 2. And then after fork join, this was just having a delay of 10. So this also started executing here after fork join with a delay of 10. And along with this, all the processes which are inside fork join will also continue execution. So here what will happen, in simple words, if you had to understand, the parent process is initial block. Okay, so inside initial block, how the statements would have executed if the fork join was not there? Say the fork join was not there, then this display statement would have executed at time instance 0, right? This display statement would have executed at delay of 10. 10. Okay, now I'm considering the fork join is not there because it's join none. So then this statement would have executed at a delay of 10, because before that one statement was having a delay of 10. So that's why this got executed at a delay of 10. And this particular statement would have executed with a delay of total 20, because 10 this and 10 this, 20. So after fork join, this statement got executed with a delay of 20 total. Now, but fork join none is present and it will execute after a delay of 10, because before this fork join the delay was 10, and then each and every process inside this fork join none will execute in parallel. So the first statement which should get executed in fork join, see, this is one process, this entire is one process, and this is one process. So the first statement which should get executed is this, because it was having a delay of 0, but before that the delay of 10 was there. So 10 plus 0 became 10. This statement will execute at time 10. Here if you see, this statement got executed at a time of 10. Then at a time of 20 this statement will get executed, right? Thread 1 inside fork join at the time of 20 got executed, and at the time 20 even this statement will get executed, and finally this will get executed at a total delay of 10 plus 20, which is 30. So at 30 this got executed. And what happens if you disable? If you Now remember, this is fork join none. None means it does not stop the parent process at all. So if you disable fork join none, it is behaving as though as fork join doesn't exist at all. So here if you see, it is just displaying the statements before fork join and after fork join. That's it. Because here as soon as you came out, you said disable fork, then it won't matter if any of the threads inside fork join none has completed or not. So in this case none of the threads have completed, but still it has come out, and since I have disabled, it will not allow any of the threads to complete also. It will just execute the statements inside your parent block, which is initial block. I hope with this fork join any and fork join none is well understood. Now let us see another very interesting example of nested fork. If you see here, I have fork, and here also I have fork. So I have fork inside fork. Now let us see how this executes. These are same. This is same code as we discussed previously. Only instead of begin and, if you remember, here we had begin and. So instead of that, what I did, I replaced it with fork join any, and I put it inside fork join any. If you see fork join any, and once both these fork join any are completed, I am disabling the fork. Now let us run this example and then we will analyze the output. Now if you see, these two statements should get executed first. These two statements got executed first. Now, this is fork join any. It means if any one thread completes, it will come out. What are different threads inside this fork join any? This is one thread which has a delay of 10. This is another thread. Fork join any itself is another thread. In this thread, one statement is having 0 delay and another statement is having 20 delay. And if you see, this is join any. So as soon as one statement, which is first statement, will complete execution, it will come out. So this will come out at the delay of 0. This has delay of 10, one process. This is another process which has a delay of 0. Why? Because it is fork join any, and this has a delay of 10. So one thread which is fork join any is going to complete with a delay of 0. Inside this, if you see, this will complete with a delay of 0, but before this there was a delay of 10. So total at a delay of 10, you will come out of this fork join any, and this fork join any is also inside fork join any. So once you come out of this, you will also come out of this. It means you are going to come out of this at a delay of 0. Overall this fork join any is executing at a delay of 0. Only this one statement will execute and it will come out. So if you see, only one statement got executed at 10 and it came out. And then these two statements got executed. Now, let us understand what will happen if I replace this join any with join means everything should get completed, only then it will come out. But in this, only this remains join any, so here only this statement will complete, this will not complete. So this statement completes at time total delay of 0. Inside fork join, if you see the fork join, this statement completes with a delay of 0, this delay of 10 and this delay of 10, which means 10 plus 10, this at 20 time it will complete. This one it will complete at time of 10 only, and this one will complete at a time of 20. So total this fork join, total delay of fork join is only 10 because there are three different processes. The first process is having total delay of 10. The second process has a delay of 0 because this is join any. It means as soon as first statement completes, this join any completes. So it has a delay of 0. And the third statement has a delay of 10. It means overall fork join is having delay of 10 only. So if I run this and see the output, see these two statements before fork join got executed, then this is having delay of 0. Inside the fork join it has delay of 0, but before fork there was a delay of 10, that's why it got executed at time 10. And as soon as this statement got executed, the second statement inside this thread is not going to get executed because it is join any. So this display statement you will never see. You are never seeing this display statement. And these two statements will get executed at 20 time. 10 plus 10, the total delay will be 20 for this, and same 10 plus 10, the total delay will be 20. So at 20 you see these statements inside these two threads, thread 1 and thread 3 got executed, and now all the threads inside fork join completed. And once they completed, they came out and they displayed this and the next statement. I hope this, with this example of nested fork join and fork join any inside fork join any, fork join any inside fork join, now you are very very clear with the fork join. If any example comes, you can solve it. Go through this video again and again until you understand fork join thoroughly, and try to execute these codes by yourself. Try to innovate codes, try to create your own codes, try to run them, analyze output, and make this fork join concept very clear in your mind. To stay tuned to such quality content, please subscribe to Sweetie Speaks official YouTube channel. See you in the next video.